Okay, so the bell rang again. Someone finished this question. We talked about, I think these were the numbers we were using. If not, it's the same idea. Uh, with a between statement like this, we would normally just leave it this way, and whatever this expression was, we'd solve for it, solve it to all, or do the opposite operations to all three parts. But with inequalities, including absolute value like this, you want to treat them a little bit differently. We're basically going to rewrite that first. Okay, so I'm going to rewrite, I'm going to write absolute value first. So the absolute value of x is greater than 8. Okay, then I'm going to rewrite that to where it says absolute value of x is less than 10. Okay, and understanding that this whole thing was a between statement, and between means intersection or the word and. So I'm gonna put and in here. Okay, so when I'm done, our solution should have this criteria and that criteria. Now talking about what we did today, we have absolute value greater than 8. That actually meant that we had to go absolute value of x is greater than 8, or x is less than negative 8. I gave the two results. That, and if I put a number that's bigger than 8, like 12 in here, 12, absolute value of 12 is 12, greater than 8. That's true. But if I put negative 12 in, which is what this is saying, negative 12 should be in that range, absolute value of negative 12 is bigger than 8. So okay. So that's what that breaks down to, those two inequalities. Still got the word and in here. This breaks down to two inequalities as well. We just write it this way. Negative 10 is less than x is less than 10. Okay? So our final production here has to have this and that idea. So what I'm going to do is I'm going to graph both those concepts. I'm going to graph this one, x is greater than 8, or x is less than negative 8. So that would, if 0 is here, let's put negative 8 there, let's put 8 there. If I were to graph those, x being greater than 8 would be those quantities. Less than negative 8 would be those quantities. Okay. Now, this stuff here, negative 10 to 10, if I plug those in, let's do some blue, negative 10, positive 10. What that's saying is that x is those values. Okay? But we want x values that have this criteria and that criteria. So graphically, that's where these two things overlap, and that's going to be those values there and those values there. So how do we write that in interval notation? Those purple values go from negative 10 to negative. For some reason, that thing wants to keep coming back. Negative 10 to negative 8. And over here, 8 to 10. And we'll union those. Okay. Think about any number that you take out of that interval. Should be able to be plugged in right there. It should satisfy that condition. Okay, if I plug in 9, 8 is less than 9, and 9 is less than 10. 9.5, 8 is less than 9.5, 9.5 is less than 10. I should also be able to put in something like negative 8.5. Okay, 8 is less than absolute value of negative 8.5, which is 8.5. So 8 is less than 8.5, which is less than 10. So that makes sense. So these values, I think these were probably pretty obvious that those should be part of our solution. But these, maybe not so obvious. And that's what this process will provide, is the addition of these. Now you do the exact same thing if, if I had like 8 is less than absolute value of x plus 2, less than 10. I just now have something I have to solve for in those two things and solve for in that one. Makes it a little bit harder, but in the end, you'll get down to something like this. Your results are not going to be, these kind of mirror each other. Negative 10, negative 8, 8, 10, same numbers, different signs. Won't happen here, but you'll get something similar.